So for our Aldol condensation product, which in my case is 57B, we're going to attempt to get some GCMS spec data on it. We'll also want IR data on that, which I've already obtained, and NMR data when the instrument works. So for a method file, it's not clear exactly what we're going to need for a method file for this material, but since it's pretty high molecular weight, I'm thinking that the same conditions for the Diels-Alder reaction might work. So we're going to use the Diels-Alder 2021 method, which starts at 200 degrees and holds for 2 minutes, and then rises at 15 degrees C per minute to 245 and holds for 4. So that's a 9-minute run. We have a solvent cut time of 2 minutes. And hopefully our compound will come off in that range. So I'm going to go to sample login, and I'm looking at 57B-2 because the IR was -1. And under file name, I'm going to call this Aldol condensation round 1 because I may need to run more than one. And this is the product of Aldol condensation between K1 and B2. And we don't know what those are. Vial number 1 is where I put it. Injection volume is 0.1 microliter. And I did dilute that sample about 4 to 1 because it was probably too concentrated the way it was. So we're going to OK that. And we're going to download those parameters, and we're going to let this GCMS spec do its thing. And while the GCMS spec is doing its thing, we're going to go get the melting point on this product. So I brought a melting apparatus into the lab and stuck it in my hood. I'm going to turn that on. I'm going to grab a chair. So unfortunately, the melting range of the possible Aldol products is quite large. The potential range, everywhere between under 100 degrees to almost 200. And I want this to be rising at about 2 degrees C per minute at the melting point. But since I don't know which one of those compounds I have, I don't know how fast I need to let it rise. So we may be here a while. It's always a good idea when you're running a melting point to take a little bit of that compound and put it on a watch glass so that you can make sure it's ground fine and you don't get any kind of large chunks in there. I'm just take a little bit of my solid out. I've got plenty, so I don't have to really worry about wasting it. Set that aside. That's way more than we need for NMR, assuming the NMR ever works again. And then I really want it to be kind of uniform. I want it to be as powdery as possible. I hope the camera is pointing at it and not somewhere off into the middle of nothing. I think it's there. So I'm going to break that up. I don't want these needles. I kind of want it to be powder so that it will go in a nice uniform packing into the capillary. Since the melting point is quite different for all 6 of the possible products, unlike in the morpholine lab, for this one, the melting point actually could be a very useful piece of data. So that's broken up pretty nicely. Just going to take my melting point capillary and invert it and tap it on there a few times. And I'm shooting for like 3 or 4 millimeters of material. Pull that off the top. That looks pretty good. And I can just tap that on the bench top. You can also throw it down one of those glass rods. But in this case, I think just tapping it on the bench top is going to work pretty well. So you get a nice uniform bit, about 3 millimeters or so. It should work well for a melting point. We don't want too much, or it can take longer to melt and extend our range. We can insert that into the central slot. And then maybe you can see it if the camera is lined up right through that magnifying glass. And right now our temperature is at 25 degrees. So we're going to raise this up to about 3. And I have no idea if that's a good setting or not. I hope it's a good setting. And if it's not, we'll run another sample. Too many samples here. 56R, 7B. Unfortunately, I don't have 2 cameras, so I can't set one looking through the magnifying glass and the other one looking at the top, which would be optimum. So this thermometer is a 400-degree thermometer. And we should see it start to rise fairly quickly at some point. I'm going to leave that there, right, because I may need to run it again if it melts too quickly. But it looks good in there at the moment. We're up about 32 degrees so far. So, rising fairly slowly. I expect I'll have to turn this up to somewhere around 6 probably by the end, but I don't want it to go too quickly and miss that melting point. Give that a little tap actually. See if I can get that in there a little more uniformly. Now we're up around 40. It's rising at a pretty decent rate for that lower melting point. Obviously I could be rising a lot faster if I knew that I had a higher melting point, but I don't know that. So I think I can raise this to 4. At this heating rate, even for that lower melting point, we should be in good shape. So we're at 42. Nothing's happened yet. Up to 50. Still nothing. And I know nothing's going to happen until it hits about 80, so let's wander over and see if the mass spec is telling us anything yet. It's giving us an insert counter warning. Well, that's normal. So if we look at the method detail, we'll be able to see it. So there's nothing between 2 and 6 minutes It's possible that it came off too quickly. I think that's relatively unlikely. It's also possible that at these high temperatures we get some reverse aldol, but in the absence of water, we really shouldn't be able to reverse that aldol condensation. We've never actually run GCMS back on the aldol condensation products before, so I'm not 100% certain that they are volatile enough to come through. We may have to mess with this method. Not much action. Still nothing. So it looks like under these conditions we're not detecting it. As I say, I don't think it's because it came off too quickly. I suspect it's because it's not off yet. So I'm just waiting for this to finish, and then I'm going to go and edit that method. While it cools. So the GC has gone not ready. It's cooling back down. I'm going to save this method file. I'm going to call it Aldol 2021. And then I'm going to go in here and I'm going to change that rate. I'm going to still start at 200. I'm going to change that rate to 20. I'm going to hold it for only a minute. And I'm going to set my final temperature to 260. And then I'm going to hold that for 7 minutes. Actually, I'm going to hold it for 8 minutes. I'm going to hold it for a good long time. So it would be a 12-minute run. I'm going to stick with the 1 mil per minute rate. I just need to change this to 12 so that the mass spec continues to collect data. We'll save that data file or method file. And then we'll go back to sample login and call this 57B-3. And this will be round 2. And we'll OK that. And we'll run that again while we look at our melting point, which hopefully hasn't already gone too high. So our thermometer's up around 105. Hopefully our compound was not below. Oh, looks like it was one of the low melting ones. It has melted. So that's useful information. I'm going to turn this back off now that we know that we're going to have a pretty low melting point. I'll turn that off and let it cool. And prepare a new sample. if I hadn't gone over to mess with the GCMS spec, we would have had the one that melts at 180. And we would have been watching it do nothing. Because that's Murphy's law. But that's good, because now we have a pretty good idea how long that's going to need to go for. So I'm just doing the same thing I did before. Trying to get 4 or 5 millimeters worth of material in there. Putting in a little bit more than I did last time. Last time, by the time I tapped it down, it was a little sparse. So that looks pretty good. Could actually measure it. And it's almost exactly 3 millimeters, so that's good. That's about right. We just have to wait for this thing to cool. Before we put that back in. I'll just leave that sit just in case I mess it up again. Miss melting point. But hopefully I won't. Down to 100. I want to let that drop to about 60 before I put the sample back in.